Hello, this video is to explain how to do week 8 assignment. For this assignment, the hard part is to write all the reasons for every property that you mention. Look at number 13. You see that the perimeter of BCDF is 50 cm. In general, you cannot claim anything, but BCDF is a rhombus. It means if you want to find, let's say, DF, then you can find DF by 50/4. So how can you claim this? This is actually a property of rhombus, so you have to write the reason. So let me tell you the flow of this question. First, you can find out this length, which is 12.5 because of property of rhombus. And then, in order to find out AB, you need this length as well. AF is also 12.5. Why? Because ABDE is a rectangle. This is a property of rectangle. Next, you can also claim that BD is equal to 24 because it is the opposite sides of AE. It is also property of rectangle. So in order to find AB, you may use Pythagoras Theorem on this right angle triangle. But before that, you have to mention this right angle. Because this is a rectangle, so it is a property of rectangle that this is a 90 degree. So let's try to present it now. First step, writing FD equals to 12.5 cm. It is due to property of rhombus. Next, inside a rectangle, the two diagonals are bisected into 4 equal parts. So you can claim AF equals to FD. This is property of rectangle. Next, BD equals to AE. This is also property of rectangle. Before you use Pythagoras Theorem, you should claim ABD is a right angle. This is also property of rectangle. Finally, you have to write Pythagoras Theorem for this, and AB equals to 7 cm. Remember, in this chapter, because it is related to geometry, you have to write Pythagoras Theorem as well. For number 16, so you can see that ABCD is a square. So whenever you see a square and BD is a diagonal, then you should associate it with 45 degree. It means that this angle A dot boy is 45 degree. So after that, I think you find ABE would be not very challenging because you can make use of the isosceles triangle. You have base angles, isosceles triangle. You can find out this easily by using 2 separate steps. Base angles, isosceles triangle, angle sum of triangle. And then finally, you have to minus this 45 degree as well. So it means that at the first step, you can first write these two angles of 45 degree directly because you anticipated that it will be used later. It means that you can write 2 angles equals to 45 degree in one step. Then you can use one reason for 2 angles. So let's try to present. I would like to write 2 angles in one step, so that I only have to write property of square once. And then you can claim that because DB equals to DE given, so you can write the 2 angles are equal. They are base angles of isosceles triangle. After you claim that the 2 base angles are equal, then you can use angle sum of triangle, and then you can write directly like 180 degree minus angle boy dot E over 2. Or simply you just write 180 degree minus 75 degrees. Okay, because it is a fine question. So you can find dot boy equals to 52.5 degree. The final step involves no reason because it is just by big angle minus small angle, and the answer would be 7.5 degree. Look at number 19. This question is actually quite similar to the question I discussed in the live lesson this Monday. This question is related to isosceles trapezium. Here, the line BE is given for you, so it is already quite easy. At least you do not need to construct yourself. The trick of this question is how to use the fact that BCD is a rhombus. So sometimes you will overlook that rhombus is actually a parallelogram as well. So it means that it inherits all the properties that parallelogram has. For example, opposite sides of parallelogram are equal. So you can say EB equals to dot C. Because given that AB equals to dot C, AB would also be equal to EB. So this will be very useful later. Apart from parallelogram properties, you can also use rhombus property, which is these two angles would be the same. So you can say angle ECD also equals to 54 degrees. So after you find that the total angle, the whole angle is 108 degrees, then you can find out this angle by interior angles EB parallel to DC. How can you know EB parallel to DC? Because it is a rhombus and it is a parallelogram as well. So the fact that EB parallel to DC can be taken for granted. So after you find out this angle, you can also claim that angle AEB equals to the same angle, which is 72 degrees, because they are alternate angles AD parallel to BC, which is given. So after you know that this is 72 degrees, you can also say BAE is 72 degrees, and the last ABE would be very easy to find. Okay, so let's try to present it now. First, you can claim that angle ECD equals to 54 degrees because of property of rhombus. Next, you can find angle EBC by looking at these two angles. The sum of them would be equal to 180 degrees. Interior angles EB parallel to DC. So you can find out angle EBC is 72 degrees. Next, you can claim that angle AEB also equals to 72 degrees because of alternate angles AD parallel to BC. Next, you can claim that EB equals to DC, and the reason you can write property of rhombus for simplicity, but of course if you claim opposite sides of parallelogram it is also acceptable, but of course because BCD is a rhombus, so every property you claim about it can write this reason, property of rhombus, easy. Next, you should state that because AB equals to DC given, so you can claim EB equals to AB. This helps us to find the base angles of isosceles triangle. After you find the two angles are 72 degrees, then using angle sum of triangle, things becomes very easy for the last step. So the answer will look like this. Now let's look at number 22. So in this question you can see that ABCD is a rhombus. So about rhombus, what properties can we use in this question? The first one, you can know that rhombus is a parallelogram, so you can make use of parallel lines. So this will be useful in this question. Secondly, a rhombus would have this property, which is the diagonal would bisect the interior angles. So it will be also useful in this question. Okay, so let's try to analyze this question. Our goal is to find out angle AEF. So first of all, you can see this 72 degree can be copied here because of alternate angles of parallel lines. And then because AB equals to AF is given, so you can also claim that angle AFB equals to 72 degree, base angles isosceles triangle. Using angle sum of triangle, you can find out this angle easily, 36 degree. And then just now I say you can use the property of rhombus so that this angle is also 36 degree. And then because given that angle FAE equals to angle EAD, so both of them would equal to 18. After that, you can find out question mark easily because you have angle sum of triangle 72, 36, 18. Adding to this question mark, then you can get 180 degree. So this is the analysis of this question, and I believe you can write the steps easily. First step is to write alternate angles AB parallel to DC. Secondly, you can claim base angles isosceles triangle after you write AB equals to AF given. Next step is to find out angle BAF by angle sum of triangle. Then the diagonal AC bisects angle BAD, so you can use property of rhombus to claim angle DAF is also 36 degree. So in order to claim that angle FAE is half of angle AF, the reason it's given because this is by the fact that AE is the angle bisector of angle FAD. So finally you can find out angle AEF by angle sum of triangle easily. Now look at exercise 8.5. So the two questions would be related to proofs which are really challenging. So look at number 4. This is a question that we discussed in the live lesson before. To prove the two base angles of an isosceles trapezium the same, the line AE is constructed for you, so it is already easier than original. In order to tackle this question, you have to know the facts that AECD is actually a parallelogram. Why? Because AE parallel to DC, which is given for you, and also AD parallel to EC. Already you have two pairs of parallel lines, then of course it is a parallelogram, without stating any reason. Because it is a parallelogram, the opposite sides would be equal, so you can claim that AB, AE, and DC are equal. And then base angles of isosceles triangle, corresponding angle AE parallel to DC. So the proof will be done. So you try to write yourself. I only give you the first step, how to write that AECD is a parallelogram. You can write in these steps. Remember, there should be no reason after that. This is by the definition of a parallelogram. You have two pairs of opposite parallel lines, then this is a parallelogram. This is actually condition 5 that I mentioned before when talking about 8.3. Okay, so everything has been explained. I write up to here and then you try to complete the remaining. Lastly, look at number 7. This is a very typical proof question. So you can see that in order to prove AB parallel to DE, you may need to find some equal angles. Your goal may be to show ABE equals to BED. If so, then you can use alternate angles equal to prove that AB parallel to ED. But how to show that these two angles are equal? The hint for you is to prove congruent triangles. So it is very often that in grade 9 question, you will not have any part A prove congruent triangle. You have to imagine yourself. You have to think that which two triangles are congruent. So in this question, the hint for you is that you can prove triangle ABC congruent to triangle dot EF. If you can do so, then of course the two corresponding angles must be the same. The first condition you can use is AC equals to FD because it is a property of square. The second condition, obviously, you can write BC equals to EF because this is given. Second. And then the third one would not be very obvious, but you can use the property of square because this angle is 45 degree. This angle is also 45 degree. Then the adjacent angles on straight lines would be 135 degree. So you can use this to show that angle ACB will be equals to angle dot FE. However, this is a proof question, so you have to show clearly that the angle name. Okay, so let me remind you about it. You have to write every angle name first. Don't just write 135 degree or 45 degree directly. So finally, you can use SAS to prove congruent triangles, and then you can use corresponding angles, congruent triangles to show that ABC equals to dot EF. The two angles being the same, then finally you can write alternate angles equal to prove for parallel lines. Okay, so this is the idea, and I hope to see your answers. I don't give you the answers now. Okay, so that's all for this video. Goodbye.